who pioneered this journey of becoming a software company and going on this journey of becoming a software company are now starting to build new skill sets around becoming a data company. And so there's a shift happening. There's an urgency of getting skill sets around being able to build and manage and analytics across the enterprise. And there's a lot that we can learn from the two journeys. In fact, and frankly, the journey of digital transformation really is not just one about software. It's actually the combination of both software and data. So it's helpful to look at what the modern digital enterprise looks like on the inside. If you think about the inside of the organization, you're building software, you're releasing it, letting users and customers work with that software. In the process, you're generating a lot of data and collecting that data and distributing it to larger parts of the organization and trying to derive insights and analytics that you can then use to go through the cycle again to build more software and release it and try to build what the market wants. And in that sense, really the two key activities that happen in the organization are around building and operating software and learning and responding from the marketplace. And DevOps and DataOps play key roles in this journey, as you can see, sort of they're at the boundary of, between building software and releasing it, and between collecting data and making sense of it. And so, on both sides of the coin, you've got, software on the one hand trying to accelerate activities and data on the other hand trying to inform all activities. So both competencies are quite critical in order to be successful in the digital transformation journey. So there's a symmetry that emerges from both sides of the coin. And if you think about it on the organization side, on the inside of the organization, you're building software, you release the code, have it be facing the customer, where customers are using the code or users are using the software. They're generating data in the process of using that software, which you're then trying to pull back into the organization to use it to learn from and then continue this cycle, this virtuous cycle of digital transformation. So if there's such a symmetry between software and data, maybe there's something we can learn from the world of software that we can then apply to getting better at data and doing it much faster than perhaps the software journey took. And so one thing to look at is the earliest days of software, of the software journey of becoming a software company, which was really oriented around how do we build and release software quickly. So the goal really was, if I have an idea for something that maybe makes sense to release, let's say you have an idea for an app, let's say Uber, how do I go from an idea to something running in production quickly, where the time is essentially zero. You think of something today and 2 hours later it's in production. In fact, in the early days, organizations such as Amazon and Google were releasing software hundreds of times a day. And so most organizations wanted to get to that level of sophistication. And the reason for that is very simple. You want to be able to release software quickly, to learn from the customers quickly, to minimize the entry of other competitive offerings, and of course to adapt to the market as it shifts. But they also had a number of challenges. Like, not all of them were automated, so there were complex manual workflows. Between the time that somebody develops software to the time it actually shows up in production, there was a lot of IT work that had to be done in packaging up the artifacts, deploying them into configuring release production environments, deploying software there, and making sure it's working. And anytime it failed, because these past processes were manual, it took a long time to recover from that. And even when it did fail, it was not clear whether the problem lay with the deployment of the software, the configuration of the production environment, or there's actually a bug in the software from the developer side. So it wasn't quite sure if the problem lay on the IT side or the developer side. And so the essence of the challenge really was, we want to be able to release software quickly and safely, right? Which is to deliver software quickly to production and not break something that's already working in production. And the solution that the industry as a whole came up with was this notion of DevOps, right? Where we want to break down silos between teams, people on the development side working with people on the IT side, building processes, building automated processes that you can iteratively improve over time, and as a result, be able to release faster and more reliably. And so on the one hand side, you've got this shift in mindset and cultural process in the organization around DevOps, but there was a set of technologies needed to enable that process to happen at scale. That really was this notion of infrastructure as code, being able to build and deploy production environments, development environments with the same code and same configuration that led to consistency between development and production that reduced the number of problems that would happen in production. And as a result, the combination of the two allowed you to release software much faster, to deploy it faster, recover quickly from errors, and do so more reliably because it was always the same software that was running to deploy these environments. And it was designed for incremental change. You could keep tweaking the software, keep improving the configuration, the provisioning of IT infrastructure, the virtual infrastructure. And because you can release more, more software faster, you obviously have better customer satisfaction. You're able to release software that they're looking for, better product market fit, less downtime. And of course, the purpose of this journey was for these teams to work together to help the business succeed, to be more business focused. And so that's sort of been the journey on the software side. And so what's happening on the data side? When we look at the world of data today, when we think about the kinds of data that's being generated, really it falls into two kinds of categories. There's business critical data, so things that are traditional to businesses, to enterprises, things that are relatively slow changing. They're relatively smaller, but they have a long-term value, things like customer names and addresses. On the other hand, you've also got things like business context data, things that tell you about the context in which the enterprise is operating, and data that keeps on changing, things like stock values, IoT measurements, log values, logs that you're generating, Twitter firehose. It's constantly changing data, retail clicks, social signals, etc. But it's very very rapidly changing, much larger, and it has value, but only in the moment. And what organizations are trying to do is to combine these two sets of data to derive deep insights, using advanced techniques like AI and ML. And to answer complex questions like, well, what should I recommend for such and such a customer based on what they recently liked on Facebook? So you can see how they're combining data, business critical data, which is my customer that I know about, with what they recently did, their current recent activity on social network, for example, and trying to generate insights that can affect the business immediately. And that's really the kinds of activities that most organizations are trying to do. And so we end up in a situation very similar to the software world in the early days, which is you want to be able to go from raw data to sophisticated, actionable insight as quickly as possible. From data to insight with near instantaneous journey of that translation. And the reasons are pretty much the same. You want to be able to learn from customers quickly. You want to adapt to market shifts, and you want to, by being able to respond to customers quickly, minimize the potential for some competitive entry to enter the marketplace. And so you want to retain your customers and expand your customer base. And you have very much similar challenges as well. You've got complex manual effort to move data to derive analytics. There's a lot of different tool chains that people are trying to orchestrate together and connect and integrate together. There's a fragmented data landscape. A lot of time data engineers is spent on low value activities, so there's poor developer productivity. And then once you build things, there's unclear ownership, and we'll see what we mean by that in a couple of slides. So essentially it's the same set of problems again, but just in a different manifestation in the data side. So you want to deliver insights quickly, but you don't want to break software that's running in production as you move data from production to analytics environments. You want to remain compliant. You don't want the sensitive data to be exposed, for example. And any large-scale data insights that you're generating, you don't want new updates to those algorithms to break anything in production. So very much similar sets of problems. And so the solution, part of the solution that organizations have come up with now is they're starting to come to the same realization, is that we need more collaboration. We need to be able to collaborate together to ensure that the data flows between the people who generate and manage the data and the people who need to consume that data to derive insights. And we want to do this quickly. We want to be able to deliver this value fast. And the question then becomes, well, we already know what the process change is. What is really the technology change? What do we need to do on the technology side to really make this possible so that organizations can be successful in this journey of deriving insights? And I would like to present that, I believe that data transformations really are critical to this. They're very foundational to be able to transform that data, to be able to process and add value to data through the application of business logic and convert it into valuable insights. And we'll see what that means in a couple of slides. And so essentially, you get the same set of benefits. You get this ability to do something in a repeatable fashion. Because it's repeatable, it's low risk. You can incrementally change it. It's very fast to do the data transformations and deliver data to different parts of the organization. And of course, by being able to deliver data quickly and insights quickly, you're able to satisfy customers better, and as a result, derive overall business success by collaboration. So if you think about why data transformation is critical, think about the modern enterprise data landscape. You've got lots of different data repositories. You've got things like databases, data lakes, data warehouses, streaming data sources, and they're all fragmented. They're all different parts of the organization. They're all siloed. And in order to derive insights, you really need to connect that data. You need to move the data. You need to find a way to unify that data, to integrate that data. And part of moving that data around is to do transformations. You want to transform one schema into something that makes sense in a different repository, or to make so that you can store it in the same repository. So, for example, you can run analytics. But in addition to that, you also want to be able to pull data out of these repositories to build analytic applications. So there also you need to do data transformations, to have unified schemas, to do data translation, do data integration, do data cleansing. There's lots of different sets of transformations that you need to do to the data that are very foundational. In fact, I believe that the fact that data transformation is central to this journey of becoming a data company. So just like you had on the software side, in the early days, we had infrastructure as code being very foundational to being able to build modern cloud native software. You could build, once you had automated ability to deploy infrastructure and configure infrastructure, you could then think about building CI/CD pipelines. You could then think about building microservices on top of that, and then even larger sets of abstractions around cloud native. And as you build more and more sophisticated, complex layers of abstraction on top of this very fundamental capability, you could then start to become, in a very real sense, a software company. And I think the same thing is happening on the data side, which is that once you master this ability to do data transformations and to do that at scale, given the kind of data and the scale and size of data that we have today, you can then start to layer on additional, more sophisticated, complex capabilities like data curation, data analytics, AI and ML, and of course other abstractions and analytic applications that you can build on this data. So as a collection, you can master that, but also the data side. And I think the data transformation is quite as fundamental as infrastructure as code was. So what do we mean by data transformation? It's really, data transformation is a very generic term, and it's been used a lot in the past in various different contexts. Least of all, of course, traditional ETL has been around with us for a long time. But if you look at the nature of data, as we talked about earlier, the nature of data is changing dramatically. You've got business critical data that's changing slowly, growing slowly, but the business context data, things that are time varying, growing very fast, and have a short window of time of value, is growing very rapidly. What you need now is to be able to do this data transformation differently than what was required in the past. Before, what you were really focused on was cleansing and deduplicating data and validating schemas in order to ingest into data warehouses so that you could run analytics and dashboards on top of them. What you need to do now is process very large scale sets of data and not just do simple things like cleansing and deduplication, but apply complex algorithmic transformations, business logic, build AI and ML, do statistical analysis, mix the data, enrich it with other data sources, lots of different activities that need to be done. So this nature of data transformation is fundamentally different in the modern data processing sense than it was in the traditional ETL world. And the way it's being done right now is kind of similarly short-sighted in the sense that we have in organizations different sets that are focused on doing data or business. So they take a sample of the data and they try to make sense of it and they prototype with it. And then they hand over whatever business logic they come up with, whatever sense they've made of the data, to a different team to build software that can run at scale, for example, with Apache Spark or the Hadoop family of technologies. And what happens in the process is that you have all kinds of errors that happen, right? On the one hand, somebody built something, some business logic here, and there's going to be some mistake that happens in translation. Somebody maybe didn't understand something, or they understood it, but they made a mistake in implementing it, so you're re-implementing it at scale. There's delays and bottlenecks because there's only one set of people who are building out various different algorithms in business processing for different teams in the organization. So, of course, there's a bottleneck that gets created there. And of course, there's unclear ownership. When you build and deploy something at scale and it doesn't work, whose fault is it? Is it really the fault of the first team that developed the business logic, or is it the fault of the second team that operationalized it at scale? And so it becomes a very messy situation where you're trying to make sense of things. And not to mention the fact that the software that you write here for production deployment tends to require skill sets that are very sophisticated. If you're using something like Spark, you want to be able to understand distributed data, to be able to do thread management and synchronization. So there's a skill set of distributed computing that's required that goes beyond just understanding the business and the data itself. And that increases the friction in terms of being able to build and deploy data and analytic applications in production. So what I believe is the solution to that really is to have a simpler approach to doing computations, which is this notion of relational compute, where you want to take advantage of the abstractions that people have in their minds. They've been using and working with data for the longest time. They have a relational table-oriented structure and abstraction in their mind. They're very familiar with the SQL skill set. They know how to write business logic using languages like Python. Perhaps they don't have distributed system skill sets. So how can we allow people to build very sophisticated skill sets by taking away the complexity of distributed systems and allowing them just to simply focus on the business logic, to think about table abstractions, to think about simple code and functions written in Python, and allow the underlying technology platform to really build and to read in data from different sources, build in-memory abstractions that you can write code against, and allow the developer to simply write business logic focused code. And what that allows you to do then is not only are you using simpler skill sets that are readily available, but you're also building code very quickly. You're able to debug it much more easily. You're able to deploy it at scale, and you're able to deploy it not just in development environments, but also in production environments with zero changes. And that's essentially what Xcalar does, is that Xcalar provides you the kernel of capability that allows you to build more and more sophisticated data capabilities. The Xcalar platform allows you to take data from various different sources and transform it and then deliver to a different set of locations, whether the data lakes, streaming data sources, data warehouses, or anything that makes sense in your enterprise environment. And to do this at scale, to be able to deploy 2 petabytes of data, to be able to do billions of operations in parallel, and do this with much lower total cost, at 1/10 the cost of typical solutions like Apache Spark, and much higher developer productivity. And the way we achieve this higher developer productivity is through an IDE that allows you to focus simply on writing business logic, simply on exploring the data, and not work with billions of rows of data at the command line. You have a very highly productive, highly visually engaging IDE where you can write SQL and Python, you can explore the data, you can interactively work with very large table sets that are billions of rows of data, and you can generate data flows, data transformations that step by step can transform the data from source to final form as makes sense for your organization. That's really what drives the 5x developer productivity. But then to also deploy this with zero changes to production, with a set of tools that help you with troubleshooting, system monitoring, resource monitoring, scheduling, and sort of the full feature set of production deployment tooling that you would expect from an enterprise product. And that's what really leads to the 10x lower TCO. And so with that, I'll stop with the advertisement and just encourage you to join another session that we're having later today if you want to learn more about Xcalar. It's called Complex Data Transformations Made Easy by my colleague Nikita Ogievetsky today at 4:15 p.m. To 4:45 p.m. So hopefully we'll see you there, and I'd be happy to answer any questions that you may have. Made it time.
Yeah, thanks, Karun. It is fascinating to know how the world is gradually transforming from software driven to data driven. Let's see if attendees have any questions for you. Jitesh, do we have any questions?
So far, no, don't have any questions yet.
Okay.
We had some little difficulty with the audio, so it was like cutting in and out a few times, but presentation was excellent. Thank you very much for all the insights. Really appreciate it. We just got a question. Have you seen graph databases used?
Sorry, what was the question again?
Have you seen graph databases used?
Of course, I mean, graph databases are quite common, especially when you're trying to relate high dimensional data and you want to be able to do, understand connections between data. So it's being used. I think the issue really isn't about a particular type of data source. It's really about how do you combine and transform that data so you can make sense of it in the context of other data. So of course, graph databases are, I think, increasingly growing in popularity and used for lots of different purposes. Especially if you have things like semantic networks that you're trying to make sense of one thing with respect to other things like life sciences where you have complex biochemistry that you're trying to model. There's lots of different relationships between lots of different entities. So graph databases are very useful in those types of settings. Absolutely. Hopefully that answers the question. I'm not.
You did, thank you.
Yeah.
Any other questions? Please put your questions in the question Q&A session so that Karun will be able to answer now.
Looks like there's not many questions. Hopefully it made sense. If I went too fast, I think I heard somebody say the audio was cutting in and out. But happy to talk about anything I'd presented that didn't make sense also.
Yeah, we had only a few instances where we had some issue with audio, but overall it was perfect. Thank you very much.
Okay, great.
So, no questions so far. If you do have questions, please post it in sessions Q&A.
Perhaps we can.
Yeah, there's one more question. Have you seen your product used in a data for good space? And maybe discuss an example.
It's a good question. I'm not sure what you mean by a data for good space. So more like a nonprofit situation. Perhaps you can explain.
Ro, can you please clarify? Yes, it's in government or nonprofit.
So far, we've had commercial customers, not so much government customers, but I think I would imagine it's the same at the end of the day. And from a technical point of view, the data is very much similar, whether it's government or commercial solutions. I would not be surprised if organizations used it in the sense that you can combine lots of different data sources, whether it's a data lake sitting, CSV files sitting on a data lake, or JSON files sitting on a data lake, or it's a streaming data source like Kafka, or it's a data warehouse like Snowflake. There's lots of different data repositories. from which you can gather data and sort of create a relational abstraction and then write code against it using simple SQL statements, simple Python functions, and Transformat. And whether you're doing that to, to let's say understand your customers on your website better, let's say a retail context, is no different than understanding, for example, public health questions, things like COVID-19, and trying to see whether, hopefully in the future, when the vaccination is available, what kind of impact it's having on people getting the vaccination. Is it having particular types of outcomes for particular sets of patients that have particular things in common? That kinds of complex analytics is really what Xcalar is designed to be able to solve, and to do so at very large scale. So I would very much expect the government and nonprofit would leverage Xcalar to derive deep insights to serve their constituents better. Absolutely.
Great. Thank you very much, Karan. We have one more question from Shannon. And the question is, for data security requirement, is your system authorized to handle healthcare data, especially when patient, medical, and identification information are involved?
Yeah, so there's many different regulations, and a lot of times it's not just the regulations, also the organizations that have their internal policies that come with data management and data governance. The system does come with a number of libraries. For example, if you want to do data masking, and I think we've seen organizations leverage it to be able to anonymize data and to be able to use it in a way so that does not affect, for example, patient confidentiality. So I would imagine for sure that you can use it in the healthcare context as well. And we're continuing to work on getting approval for compliance with different regulations. But at a very basic level, things that you can do and take advantage of, the system does come packaged with, for example, data masking capabilities. Not to, of course, in addition to enterprise security features that you would have that you would expect, with authentication and authorization based on enterprise security systems and settings.
Excellent. Thank you, Karan. Again, as a reminder, if you have any questions, please do post in session Q&A.
It's a quiet crowd on a Sunday morning.
No more questions yet. And Carol, while we wait for others to ask questions, so we do have the material, the PowerPoints that you have walked us through available, correct?
Correct. I think I gave it to Navina just this morning. It was uploaded. The latest copy was uploaded perhaps an hour ago. So whatever is there now should be the most recent one. Perhaps Navina can confirm.
Yes, I do have that. Maybe I can share. And I think that is also uploaded in Wova, I guess.
Yeah, it's available in Wova.
Yeah.
And of course, please do stop by our booth and ask us questions. We'll be happy to answer questions. And please do attend the session later this afternoon with my colleague Nikita, talking in more detail with more hands-on approach on how to use the platform to solve data transformation problems, and an example of how we did that at a large investment bank.
Okay, that's great. So if no more questions, then maybe we can end the session.
Okay, thank you, everyone. Thank you to the hosts as well.
Yeah, thank you, Karun, for your presentation, and I appreciate all the attendees for the questions and the interactions during this session. Please contact the speaker if you have further questions regarding this topic. Please provide your comment and feedback to us or the organizers on the community board, or start a discussion there to connect with others in the DataCon LA 2020 community. Thank you for joining today's presentation, and I hope you can gain some insights from this session. Have a wonderful day, and thank you for being a part of this year's DataCon. Thank you, everyone.
Thank you.